lecture, I'll be talking about data visualization and Matplot library in Python. As you may know, the purpose of scientific computation is insight, not numbers. It means that we want to understand the meaning of many numbers we compute. We often need post-processing, statistical analysis, and graphical visualization of our data. You might have heard that a picture might worth a million of data points. The Python library, Matplot library, is a Python two-dimensional plotting library that we are going to use a lot. It produces quality figures in a variety of hard copy formats and interactive environment. So we had a few examples before that we used this library. For example, for simulating random walk process, we generated a very cool graph using this library. So different plots, including histograms, bar charts, error chart, scatter plots, etc., can be generated using this library with just a few lines of code. And we can use different data structures. We can use arrays, we can use data frames, or even lists. Pylab is slightly more convenient to use for easy plots, and Matplot gives far more detailed control over how plots are created. So how we can add labels, legend, or change the scale of x-axis, y-axis, and etc. And you are going to see a few examples. Chapter 9 of our second textbook, Python for Data Analysis, is related to data visualization and Matplot library. In this slide, you see a couple of examples. We want to create graphs using plot functions. So the main function under Matplot library is plot. So in the first example, we import numerical Python. So you can imagine that the data structure is arrays. And then we import matplot library.pyplot as PLT. So we assign this short nickname. So when we call it, it refers to matplot library. X, we use arrange function to generate data between minus 3.14 and 3.14. They are all evenly spaced by 0.01. Then we apply the sign function, and that's one of the reasons we use arrays as data structure, because when we apply the function, it automatically will be applied to all elements in that array. And then we want to plot x and y. So y is the sign of x, and then we show the plot. In other example, the data structure is a list. So x is equal to a square bracket. So when you see a square bracket, it means that the data structure is a list. 0.1 times I for I in range 50. So it generates a list with 50 items, and you can see the for loop is inside the square bracket. And then I want to apply cosine to all elements. Because it's a list, we need to write a for loop which goes through all items in that list. So ys is equal to np.cosine. So this function is defined under math module and also numerical Python. For example, you can have math.cosine x. For x in that list, so that for loop makes sure that we go through all items, and then we apply the cosine function to those items. Then we can plot them. So plt.plot xs will be the x-axis, ys values for the y-axis, and the marker is dots, and we want to add label, fitted curve. So label equal to this string. And then we want to add labels to y and x axis. So plt.ylabel, and then you can add the text that you want to show for ylabel. The same for xlabel. So ylabel and xlabel are a reserved word which assign text or a string to your axis. And then we show the plot. Let's run this in a notebook, and you can see what the results look like. So here, first we import libraries that we are going to use: numerical Python, pandas for data frame, random, and matplot library. Then we use the arrange function, the first example that we just discussed. So np.arrange between -3.14 and 3.14. The step value is 0.01. So let's run it. Let's print it so you can see it's an array. If you want to know its size, then you can apply the shape. So 628 data points. Then we define another variable y. Then we apply the sign function, sign of x. So let's check the size of y. So y dot shape. Again, it's 628. And now we can apply the plot function. So first we call matplot library, or its nickname plt.plot, then x and y. Then we want to see the plot. And that's what we have. So you can see the sine curve in this example. Now, in the next example, we are going to generate a list of items, and the data structure is a list. So x is a square bracket, 0.1 times I, and a for loop for I in range 50. So if you run it and if you print, you can see that it's a list and it has 50 data points or elements. And ys is another list which calculates the cosine of all items in x, but we need to add a for loop for x in x. Let's run it. Let's print it. You can see another list, and then cosine function is applied to all items. Now we can apply the plot function. We pass xs and ys. The marker is circles or dots. But here we want to assign labels. So label equal to the text that we want to show. So in this example, fitted curve. We can also add label to y and x axis. So plt.ylabel. This example, we just go with y, and then the same for x label. So the keyword is y label or x label on their matplot library. And then plt.show. So let's run this. So there is a typo here. Now let's rerun. Okay, here you go. Now you can see the x and y. We assign a label to x-axis, x and y, and the markers are circles. And y is the cosine of x values. So you can see the cosine curve Now, sometimes we want to superimpose a few curves in one figure. So how we can do this superimposition and adding details to plots? Adding legend, adding grid, and also title to the figure. So like before, we use the arrange function in this example between -3.14 and 3.14, a step value 0.01. Then we define two variables. For one, we calculate sign, and the other variable, we calculate the cosine of items in X. And now plt.figure. It means that now plot resides within a figure object. Now, when you go with this format, then you can pass figure size. We want to have a smaller figure, larger figure, and in this example, it would be like a square, 5 by 5. Then we can apply the plot function x and y1. So it means that now both plot function will be applied to the same figure, and then we add label, sine and cosine. Then we call plt.legend. Because we are superimposing two curves, we add legend. We also want to add grid, so plt.grid, and also add labels to both x and y axis. So plt.x label x, y label for y, and if you want to add a title to the whole graph, then plt.title, you can pass the text or a string. And then you see the result. So let's implement this so you can see how we can superimpose sine and cosine functions in one figure. Again, we use arrange method. We generate evenly spaced data points between these two numbers. Y1 variable calculates the sign of all items with just one line of code. Y2 calculates the cosine of items. Let's run it. Then we define the figure object, so plt.figure. Now everything will be assigned to this figure. And we can pass the fig size. Let's see, it's fig size equal to 5 by 5. You can change the numbers and then you can see how the size changes accordingly. And then we apply the plot function. We pass x and y1. Label equal to sine of x. So these labels will be used when you add the legend to your graph. And then plt.plot for x and y2, we assign a label, which is the cosine of x. Now we call the legend method. So legend adds legend to your graph. If you want to see grid, then plt.grid. And then we define x label and y label. So plt.x label, let's say just x. And then we assign title, plt.title, and this sentence, this is the title of your graph. And then plt.show, Let's run it. Let's see what. Okay, it seems that there is a typo here. Label. Okay, now you can see the graph. First, this graph has a title, it has a legend, you can see grid, and you can see two curves, both sine and cosine of x. And that's how we superimpose two graphs in one figure. Now, if you comment out the grid, if you run it, then you don't see grid in your graph. Or if you comment out legend, then that's what you see. There is no legend, but it's not clear. There is no label for each curve. So when we present several curves, we do want to show the legend. Okay. Now, let's say we want to have several graphs within one figure window. In this case, we use subplot command. And here is an example plotting the sine and cosine curves in two graphs that are aligned underneath each other within the same window. So you want to present two graphs within one window. So we generate some data points t, numerical Python arrange, and this time 0 and 2 times pi value. So pi value is also defined under numerical Python, and in this example, capital N refers to numerical Python. So if the nickname for numerical Python package is NP, then you go with NP. And then the variability space, the step value is 0.01. Now, here you use subplot, plt.subplot. So there are three arguments. The first one shows a number of rows. And I have explained it here in this slide. So number of rows is the first argument, then number of columns. In this example, we want to have each graph in one row and one column. And then the third argument is the index. Index shows the position of your graph. So for example, you want to first present sine. So now the position is 1. Then when you want to present cosine, then 2, 1, so number of the rows, the columns, and the position. And this index goes from 1 to number of rows times number of columns because it's like a matrix. So you're going to see what it looks like. When you see the result, it makes better sense. So when we define the subplot, then we create, okay, how many plots we want to have in one figure. Then we can apply the plot function. So we want to plot t, and the y value is sine of t. Then we add x label, y label, and then we can call the second, the subplot again, but here we are updating the third argument. So number of rows, number of columns remain the same, but where you want to add this plot, position 2. So after you define the index or the position of your plot, then you can apply the plot function. So then we want to plot t against the cosine. We add y label, x label, and then show them. So let's run this in a notebook. So np.arrange between 0 and 2 times pi value, which is defined under numerical Python. A step value 0.01. Now we call plt.subplot function. So number of rows 2, number of columns 1. and then the index for the first plot, which is 1. Now we can apply the plot function. We want to plot t against np.sign of t. Then we add x label, so plt.x label t. We also want to add y label. Here is sign of t. Then we are done with the first graph. Then we call subplot again. We just update the index for the second plot, or the position of the second plot. So 2 rows, 1 columns, and an index is equal to 2. Then we can plot t and this time cosine of t. Again, we assign x label and y label. And then plt.show. So let's run this. Now you can see 2 graphs in one window. So 2 rows, 1 columns. You can change it to 1 row and 2 columns. Then the first one would be sine, then cosine is under the first graph. Now let me show you. So let's change it to, so we want to have both plots in 1 row, but we assign 2 columns. Now you can see that we have 1 row, and then the first one is sine, the other one the cosine of t. Let me change it to 1. You see labels for both x and y, and we talk about formatting graphs later on, so you can change the space between these 2 graphs, or you can change the font and the size of your graph as well. So with using subplot commands, we can have several graphs within one figure. Here's another example. plt.figure. In this example, first I create an object. So plot reside within a figure object. And then I plot different values. So I define 2 objects, figure 1, figure 2. Then I plot, let's say, range of 10. And the markers are, for the first one, the marker is circle or dot. And for the second figure, it's X. And then we want to show the result. So let me quickly run this. So remember when we define plt.figure, so we define a figure object, figure 1. plt.plot, then let's, in this example, range of 10. We can change marker, let's O. So each data point be like a dot. And then I define another object, figure 2. Then I plot range of 100. This time I change marker. Now it's X. So you will see two different figures. Markers are different, number of data points are different. So that was another example to create plots. Okay. Now, a scatter plot's one of the simplest way to represent univariate data. It means that we just plot each individual data point. X-axis would be the number of data points, Y would be their value. And the plot command in this example is plt.plot. So we pass X value, and the second argument is simply just dot. So in the first example, you can see that we create X value, just random numbers using rand function. So 9 elements randomly generated between 0 and 1. Then I apply plot, we pass X, and the second argument is dot. So it means that this is a scatter plot. And the second example, now we can see, show X versus Y. Again, we are generating some random numbers, but this time we are using rand n. And if you remember, it generates random numbers from a standard normal distribution. And then we pass the size, so 2 rows, 9 columns. So it would be like a matrix. And then we define the figure. First, we plot the first row, so data 0 and all columns. Marker is X. And then we plot the second row, data 1 and dot. So let me implement this. So whenever we want to generate a scatter plot, it's just a univariate data analysis. First example, mp.random.rand. So it's an array. If we print it, you can see they're all between 0 and 1 with 9 elements. Now plt.plot. If we want to generate a scatter plot based on this data, we pass X. The second argument is just dot. Now you can see the scatter plot here. Y value, the range is between 0 and 1. And then we have these data points. In the second example, we want to show X against Y. So we generate data, so it should be a matrix. mp.random. This time we use the rand n function. The size is 2 by 9. And if we print, you can see its data structure. It's like a list of lists. The first list represents the first row. The second list represents the second row. I define a figure object. Then plt.plot. First, we want to show the first row. Marker is X. We also want to show the second row. The index is 1 for the second row, and the marker is dot. Now this is what you can see. So first off, both plots are in one figure because they are defined under figure 1. So the first row, we are using X as the marker. And then for the second row, we are using dots. And that's how we can show the scatter plot of 2 variables in one figure. Now let's go over some useful methods which helps with modifying your graph. So we can apply different markers. So far we use dot, circles, and X. So instead of dot, we can use O or circles, X, V, or hat. If we want to have lines, then you can use the dashed, double dash lines, or 1. We can also change color. Color can be set as well. G dot gives green dots, or you can pass another argument and a plot function, color equal to green. For example, if I pass another argument, color equal to G, then I expect to see different colors. So for the first scatter plot, the first row with X's, then the color is green. Now if you want to change it to red, you just use the keyword for red. Okay. Also, we can assign title. So when you create the object, then the way that we assign title or label for each axis is a bit different. So we first call the object and then use set title, then we pass the argument. So if we go with this format, then we use set underline title to define the title for the figure, set underline X label to define label for X axis, and if we want to set axis tick, then we use set underline X tick, and then a list of values. So there are different values and it changes or modifies the axis tick. So there are technically two different ways. You either call the Matplot library, then dot title, or you first create the figure object and then use the set title or set X label to define or modify the figure. Now, I would like to conclude this lecture with a few practice problems. Here there are 3 problems or examples. First, we want to create 20 random numbers and show them on a scatter plot. Okay, so the simplest way to present a univariate data. Then we want to create 2 arrays of numbers. Numbers in array X are between 4 and 9 and spaced 0.1, so they are evenly spaced. Numbers in array Y are between 6 and 11, and this value is 0.1. And then we want to plot X against Y. For this one, we also use the plot method. In third problem, we want to create a 2 by 10 numerical Python array of random numbers. Plot the 2 rows against each other using red X's. So we want to change the color and X as our marker. And then we want to add appropriate titles, X and Y labels and ticks. At this point, I would encourage you to pause the video, try to generate these 3 figures, and then compare your codes with mine, because these 3 problems help with summarizing the main points we discussed in this lecture. Okay, let's answer the first question. X equal to np.random, so we want to generate some random number. I use the rand function between 0 and 1, 20 items. And then we want to just show the scatter plot. So plt.plot, we pass X and the second argument is simply dot, and then we show the plot. Now this is the scatter plot. 20 items, the Y value is between 0 and 1 because this X, if we want to print, they are all between 0 and 1, randomly generated. Okay. For the second problem, we generate X and Y. They are all arrays. Again, np dot, we can use the arrange function to generate numbers between 4 and 9, evenly spaced by 0.1. Y variable is np.arrange between 6 and 11, and the step value is 0.1. Okay. Now let's check the size. So x.shape it's 50 data points, y dot shape, again 50 data points. Now we want to show x and y in one plot. So plt dot plot, we pass x and y. This is what you see. It's a straight line. Now we can also look at their scatter plots separately, so you can see that their values are different. So plt dot plot x, and then let's say is the marker is x for each data point, and plt dot plot y. So we plot them separately. Let me run it, and then you can see that two lines in parallel. If we want to show x against y, this is the graph that we have, but I wanted to see these two separately, so their values are different, they do not overlap. For the third problem and the last one, we want to generate a 2x10 matrix. So data equal to np.random. I use rand_n function, a standard normal distribution, 2x10. Then I define an object named fig, which is plt.figure. Now I can add subplot, I can add a title, label, and x text. So I define ax1. So I call my object fig.add underline subplot. There's going to be only one graph, so 1, 1, 1, like 3 arguments that we pass to subplot. Then I can apply the plot function, data, the first row against data, the second row, and we want it to be red and red axis. Okay. Let me run it. Now this is what we have. On X, we see the first row. On Y-axis, we see the second row. And then they are all red axis. Now we want to add title, label, and x text. So I call ax1 our graph, then set underline title. Make it a scatter plot. ax1 dot, if we want to set x text, then we pass this value, so you can add different values and you can see the difference. So this is the x text. We can also, so ax1 set underline x label. We assign a label to x-axis. Let's go with, we can do the same for y-axis. So first I set the y text. So set underline y text with the same values. So -1, 0, 1. Then we set y label. Then we can have the text. So let me run it. in order to see the labels, scatter plots, and titles, we need to run that piece of code together. So everything in one block. And when we run it, then you can see the title, x-axis, y-axis, what we define. Okay. And with that, I wrap up our discussion.